once again. Now we are coming to question 31. Question 31 is a good question. A capacitor, when it is filled with air, it is 6 microfarad. And that same capacitor, when it is fixed with a dielectric of dielectric constant K, is set in the question to be 30 microfarad, which means the K is 30 by 6, which is 5. Now, after knowing K, you just multiply this by 8.85 into 10 to the minus 12 C squared n minus 1 m minus 2 as given in the book. And then let me tell you, there are 4 choices, A, B, C, D. And let me tell you, none of what we have calculated will fit in A, B, C, D. So this is one question which also student will find it is a wrong question. It is a wrong question, so dear student, you make sure you can consult some of your teachers or your principal. You can tell them that question 31 also is wrong because none of A, B, C, D is correct. So this is the one that you should always try to stress, tell your teachers or your principals so that they can put it up to the higher authority in Delhi. So now we'll come now to another question, 28, Brewster angle. So in order to cut short, we should remember that Brewster angle is the angle of reflection, and then there will be a ray which is the angle of incidence and the angle of reflection. The angle of reflection will be, and this reflected ray will be at right angle to the refracted ray. So in that case, when there are 2 interfaces, that angle will have polarized reflected ray, and that is the condition to have polarized reflected ray, and that angle is known as Brewster angle. Now, in order to understand the relation of Brewster angle with mu, that one you can consult some books, but we'll go short to this. The relation is mu is equal to tan of IB. So here a little trigonometry is needed. Mu tan of IB. Now, this is the way we should write actually. Mu of class with respect to air is 1.5. What does it mean? The class is the second interface and air is the first interface. Now, the velocity in air divided by velocity in class will be 1.5. Suppose now I change it from air to class. So now the velocity in class divided by velocity in air will be just the reciprocal of 1.5. It is 2 by 3. Now, some idea of tangent. What is tangent of IB? Tangent of IB, in the first case, when it is 2 by, when it is 1.5, so let us say if the opposite side is 3 centimeter and the base is 2 centimeter, so tangent of IB is opposite side by base, so we'll get 1.5. So with a protractor we can get it, and then you will get IB to be 52 degree. You can see from here, 52 means approximately in maybe 56, 58. But this is a rough way of calculating the tangent of IB. Same with this one. When now it is the opposite, 2 by 3, so the opposite side will be now 2, the adjacent, the base will be 3, and here, if you use a protractor here, you'll find IB is 38. This is the beauty of knowing trigonometric ratio and their meaning. So here are the few lists of interface. Mu of class with respect to air, I have done it. It is about more or less 50 degree approximately. Mu water with respect to air is 1.33 and the angle IB is 52. Pyroclast with respect to air 65 degree. Mu of diamond with respect to glass, it is 60 degree. Mu of glass with respect to diamond, it is 30 degree. Now, when we come to the question, see the choice. IB is equal to 90. This is not possible absurd. It is absurd question, absurd choice. 0, the IB is greater than 0, less than 30. This also you cannot decide. See, look at this range. You cannot say that is correct. IB is greater than 30, less than 45. See, there are more than 45, and there may be less than 30, so this is also not conclusive, and this is totally absurd. You know why? Because tan 80 is almost infinity. So if tan IB is infinity, it means the velocity on the second interface will be 0. What does 0 mean? That means it is nothing but is an opaque medium, which is not possible. So, dear student, you have seen here that 90, 80, 75, not possible because the tan of this angle approach infinity, so not possible. So here, velocity of light waves in class is 0. How could this be justified? So it is absurd, so light is totally blocked. So velocity of light waves in the second medium, not necessarily class, in any second medium is 0, not possible. So student, this is 1 point. Question 28 is also wrong. So from here you can collect 4 marks, and from here you can collect 4 marks, and it is up to you to be interested in this, to be prompt in telling your teachers or your principal so that they can take it up. So now we will end here, but before this, before I close, I will be doing the next one on LCR. LCR circuit, which is inductance, LCR, which is inductance, capacitance, and resistance. Briefly, I will do it and I'll continue on the next class. Now, in a resistance, a battery, when we put this connection, we will get 1 ampere. See? DC voltage, a resistance allow the flow of current of 1 ampere. So, and here with capacitance, ammeter, and 6 volt again, there is no current. There will be current for split second, but it will be stopped and you will get I equal to 0. This is the behavior of capacitance with DC voltage. Same thing with a coil. A coil here is here, and then in series with the coil, you have got 6 ohm. So what will be the current? The current you'll find after say 3-4 seconds, you'll find the current is 1 ampere, which means the inductance has nothing to do with blocking the current. It has nothing to do. 6 volt by 6 volt by 6 ohm is 1 ampere. That means this has nothing to do. So in DC, the inductance has no effect. It has zero resistance. Now, come to alternating current. Alternating current, suppose now you have got 6 volt sine omega t. So let's say that in order to see the movement of the galvanometer, of the ammeter or the voltmeter, in order to see, we cannot use AC 50 cycles. Let's say we use one cycle in 2 seconds. One cycle in 2 seconds or 3 seconds, you will see the ammeter moving up and down. This one you can do. There are now a special oscillator, very low frequency. One cycle in 2 seconds, one cycle in 3 seconds. You can visualize the movement of the current. And here, for resistance, the current will be just exactly as the voltage. The voltage is sine wave, the current also will be sine wave. Pi by twice omega, pi by omega, 3 pi by 2 omega, and 2 pi by omega. This is the time, so this is one complete cycle. So here, the resistance obey the voltage exactly. See, it obey exactly as the voltage. Now, for capacitance, the first time with AC we know, for capacitance, it is very happy to receive the current. That means it conducts, capacitance conducts the current. In the previous case, capacitance does not conduct DC, but now with AC it is conducting. So this is the voltage, the full line. The full line is the voltage, and the dotted line is the current. Look here. When the voltage is 0, the current is maximum. When the voltage is maximum, the current is 0. See? Which means the current is leading the voltage. 0 maximum. That means the current is leading the voltage by what angle? By angle of 90 degree. So up, down. What here see? When it is 0, up. And then when maximum, current is 0. And then when it is minus, maximum minus, the voltage is 0, so on, so forth. So here the voltage, the current leads the voltage by 90 degrees. This is for capacitance. Now for inductance, we have now the same thing. There will be a flow of current, but see, this is the applied voltage. 6 volt sine omega t. Very slow oscillation. 6 volt sine omega t. And now what happened to the current in this case? The current also will be moving up and down, and the current you'll find when the voltage is 0, the current is not at 0, not here, not at plus, it is still in the minus. And then when it is when it is in this, it will be plus. And then see, that means the current, the dotted line current is lacking. One is leading and one is lacking. So here remember, the phase may be same. The phase may be same. See here 90 degree, here also 90 degree. But now, this is 90 degree lead and this is 90 degree lacking. So with this, I will continue for this thing. You understand now. Capacitance, the current leads. Inductance, the current lags behind the voltage. It lags behind, it leads behind. This is very important for question on LCR, which I will continue on the next day. It will be only a small, 2-3 minutes time, then I'll go to another problem. So for this time being, we can stop here. Good night.